Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 4 video on the chapter of operations on algebraic expressions, where I will discuss the last topic of the chapter, that is some special products which are also known as algebraic identities and how they are used in solving some problems. And to understand the application of the algebraic identities, I will solve all the problems of exercise 6D from the textbook of author RS Aggarwal. If you have not watched the previous three-part videos, part 1, part 2 and part 3, I strongly suggest that you watch those videos also to maintain the continuity of your study on the chapter of operations or algebraic expressions. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes, which are basically the listing of all the formulas or algebraic identities that you must remember. Uh, there are quite a few algebraic identities, which at first you might think that these are a huge list of identities. How can you remember them? But as and when you will solve the problems and use them, I think you will get used to with all the formulas and identities, and it will not be any problem. But it is recommended that every now and then, if you think that you are not remembering the formulas, you can try to write all the formulas from your memory on your notebook. So the idea is that the more you write the formulas, it will stay in your memory for a longer time. So this quick notes is nothing really special. It just lists all the important formulas or algebraic identities that is useful in solving problems on algebraic expressions. Let me go through the identities. Now the first one is a plus b whole square. You are already familiar with it. It is a square plus b square plus twice ab. Now in all these identities, a, b, they can be constants or they can be variables. I hope my quick notes is visible and the fonts are big enough so that you can see them properly. Okay, a minus b whole square is equal to a square plus b square minus twice ab. A square minus b square is equal to a minus b into a plus b. The first three identities you are already familiar with and you might have already used in solving problems. Now the fourth one says that a plus b whole square plus a minus b whole square is equal to twice of a square plus b square. Now you can check all the identities yourself, like a plus b whole square, this is number 4. So a plus b whole square plus a minus b whole square. Applying the identities of a plus b whole square, this is a square plus b square plus twice ab, and a minus b whole square is a square plus b square minus twice ab. So as you can see, if you collect the like terms and add them, you have a square plus a square plus b square plus b square and plus 2ab minus 2ab. So this is equal to twice of a square plus twice of b square, and these two terms cancels out. So we get twice of a square plus b square. Similarly, you will find the numbers, the formula 5, a plus b whole square minus a minus b whole square will be equals to 4ab, because a square and b square terms will cancel out and uh, twice AB will twice AB will get added. Now 6 and 7, they are also useful. You must also know them. A plus B whole cube is equal to A cube plus B cube plus 3AB into A plus B, and A minus B whole cube is equal to A cube minus B cube minus 3AB into A minus B. Now if you cannot remember the signs of the term of the formula A minus B whole cube, now you can consider this formula, that is A plus B whole cube. You must remember properly, that is A cube plus B cube and then plus 3AB and then multiplied by A plus B. This you must remember thoroughly. Now if you A minus B whole cube is nothing but, if you consider the formula or identity A plus B whole cube, if you replace B with minus B, replacing in this formula A plus B whole cube, if I replacing B with minus B, what do you get? A plus minus B, I am replacing B with minus B cube is equal to A cube, and B will become minus B whole cube, and 3A B is minus B and A plus minus B. This way you can, using the formula A plus B whole cube, you can also get to know the formula of A minus B whole cube. So it becomes now A minus B whole cube equals to A cube. Now minus B cube is, from the laws of exponents, you know that minus x to the power some power minus x to the power 3 will be equal to a negative of x to the power 3, because the power is an odd integer. Power is 3 is odd, so it becomes minus negative of x cube. If the power was even, if the power was even, any even power, that is even integer, even positive integer, or even any even integer, let's say 4, this is equal to the negative sign, you can ignore the negative sign, this is equal to x to the power 4. So this you know. So minus B cube, a cube of minus B will become a negative of B cube, and plus 3A into minus B becomes minus 3AB and we get A minus B. This way you can arrive at the formula of A minus B whole cube using the formula of A plus B whole cube. You just need to replace in the formula A plus B whole cube, just replace B with minus B. Okay. Identity 8 is also very useful. It is x plus A multiplied by x plus B is equal to x square plus A plus B into x plus AB. Now identity number 9, you may remember, this is a little bit complex. If you can remember it, it is fine. Otherwise you can skip identity number 9, but if you can remember it, it is better. So the identity is x plus A, it is a product of three factors, not factors, three expressions. X plus A multiplied by x plus B multiplied by x plus C is equal to x cube plus A plus B plus C multiplied by x square, and then AB plus BC plus CA, that multiplied by x and then finally ABC. Now A cube minus B cube, identity number 10 and 11 is also very important. A cube minus B cube is equal to A minus B multiplied by A square plus AB plus B square, and A cube plus B cube is equal to A plus B multiplied by A square minus AB plus B square. Now identity number 12, you may skip it. If you can remember it, it is good. Now the rest of the identities are also very useful. A plus B whole square, you are expressing A plus B whole square in terms of A minus B. and AB. So a plus b whole square is equal to a minus b whole square plus 4ab. Similarly, a minus b whole square is equal to a plus b whole square minus 4ab. So if you are given the values of a minus b and ab, you can find the value of a plus b. Or if you are given the value of a plus b and ab, you can find the value of a minus b. Now 15 and 16 are also very useful and interesting. It is a square of, or it is a square of sum of two numbers where the numbers are reciprocal of each other. So 15, so a, its reciprocal is 1 by a. So a number and its sum of a number and its reciprocal, and if you take the square of the number, this becomes the square of the two numbers, that is the number square, that is a square plus 1 by a square and plus 2 into a into 1 by a. So this is equal to a square plus 1 by a square plus 2. So this is one formula, that a plus 1 by a whole square is equal to a square plus 1 by a square plus 2. Similarly, this is but in the notes it is written in a different way. A plus b, a plus 1 by a whole square, it has been written in terms of a minus a 1 by a. So if you are given the value of a minus 1 by a, you can find the value of a plus 1 by a, and vice versa. Similarly, a minus 1 by a square will be equal to a square plus 1 by a square minus 2. So all these formulas, the more you use them in solving a problem, it will remain in your memory. Okay, so these are just the formulas. Let's now solve the problems of exercise 6D, and it will be clear how we are applying those identities to solve the problem. Okay. Exercise 6D. Problem number 1 is find each of the following products. Okay. So 1 is x plus 6 multiplied by x plus 6. So it is of the form, so this we can write it as x plus 6 square, because the same expression x plus 6 is multiplied twice. So it is x plus 6 whole square, and we know the formula of a plus b whole square. This will be a, you can consider as x as a, and 6 as b. So x square plus b square is 6 square plus 2 into x into 6. This is equal to x square plus 36 plus 12x. Whenever you find the expression, whenever you find the products, it is always recommended that you arrange the terms of the final result, that is the algebraic expression, in descending order of the degrees of the terms. So you must write it as x cube x square plus 12x plus 13. Always write an algebraic expression in such a way that you arrange the terms in descending order of their degrees. Now, what is a degree of a term? If you have not watched the previous video, part 3, where I was discussing about the division of polynomials, there I have discussed about degree of a polynomial and degree of a term. So degree of a term means the sum of the powers of all the variables in the term. Okay, so this is this. Okay, number 2, 4x plus 5y multiplied by 4x plus 5y. So this is nothing but 4x plus 5 is multiplied twice, so this becomes 4x plus 5y square. And now we apply the formula of a plus b whole square. So a square plus b square plus twice A multiplied by B. So this is 4x square is 16x square, 5y square is 25y square plus 2 into 4x into 5y. We multiply all the numerical coefficients and it becomes 8 into 40, so 40xy. Now, okay, so this is the result. So while I am solving the problem, you can pause the video and take a screenshot of the solution if you think it will help you. Part 4, it is 2 by 3 x plus 4 by 3y multiplied by 2 by 3x plus 4 by 5y. So this is nothing but also the expression 2 by 3x plus 4 by 3y 4 by 5 4 by 5 uh, so the product is 2 by 3x plus 4 by 5y multiplied by itself. So this becomes 2/3 x plus 4 by 5y whole square. Now we apply the formula of a plus b whole square. So a square is 2 by 3 x whole square plus b square is 4 by 5 y whole square twice ab twice a 2 by 3x and b is 4 by 5y. Now this is equal to 4x square by 9 plus 16 y square by 25 and plus this is 16 by 15 x y. This is the final result. Okay, let's do part 5. It is x square plus 7 multiplied by x square plus 7. So this is equal to x square plus 7 is multiplied with itself. So we have x square plus 7 whole square. Now we apply the formula of a plus b whole square. A square plus b square plus twice a and b twice ab. So square of x square is x to the power 4 plus 7 square is 49 and 2x square 7 is 14x square. Now we will arrange the terms in the descending order of their degrees. So this becomes x to the power 4 plus 14x square plus 49. This is the result. Okay, let's do problem number 2. This is find each of the following products. Okay, part 1 is x minus 4 multiplied by x minus 4. So this is equal to x minus 4 square. Now we will apply the formula of a minus b whole square, that is a square plus b square and minus twice ab. So this is equal to x square plus 16 minus 8x. This is equal to x square minus 8x plus 16. Okay, part 2, we have 2x minus 3y multiplied by 2x minus 3y. This is equal to 2x minus 3y square. This is equal to, now we can apply the formula of a minus b whole square. So a square plus b square minus twice a multiplied by b. So this is equal to 4x square plus 9y square minus 12xy. Okay. 3. Oh, I missed some parts from the problem number 1. Sorry. Okay. Let me complete the problem 2, then I will finish the remaining parts of problem number 1. Okay. So, part 3 is 3 by 4x minus 5 by 6y multiplied by 3 by x4 minus 5 by 6y. So again this is equal to 3 by 4x minus 5 by 6y whole square. So we can apply the formula of a minus b whole square. So a square plus b square minus 2 into a multiplied by b. So this becomes 9x square by 16 plus 25y square by 36 and minus 2 and 2. So 5 by 4 x y. This is the result. Okay. Part 4, x minus 3 by x multiplied by x minus 3 by x. So this is equal to x minus 3 by x square. Now applying the formula of a minus b whole square, this becomes a square, that is x square plus 3 by x square minus 2 into x multiplied by 3 by x. So this is equal to x square plus 9 by x square minus 6. Okay. Part 5, x square by 3 minus 9 multiplied by x square by 3 minus 9. So this is equal to x square by 3 minus 9 whole square. Now we apply the formula of a minus b whole square, and this becomes a square, that is x square by 3 square plus b square minus 2 into a into b. This is equal to x to the power 4 by 9 plus 81 minus 6x square. This is equal to x to the power 4 by 9 minus 6 x square plus 81. This is the result. Okay. Part 6 is y square by 2 minus y by 3 multiplied by y square by 2 minus y by 3. So this is equal to y square by 2 minus y by 3 whole square. Now you can do one thing, you can take out y common from both the terms. It is of the form a minus b whole square, but a minus b from both a and b you can see a common term of y. So if I take common y, this becomes y multiplied by y by 2 minus 1 by 3 and then this square. So this is equal to the y square multiplied by y minus 2 minus 1 by 3 square, because we know that x y square of x into y is equal to x square multiplied by y square. So now it is we have to find the value of y by 2 minus expand. We have to expand y by 2 minus 1 by 3 using the formula of a minus b whole square. So a minus b whole square is a square, that is y by 2 square, plus b square, that is 1 by 3 square, minus twice a b, minus twice a and b. So this is equal to y square, and we have y square by 4 plus 1 by 9 minus y by 3. Now if you so this is a product of a monomial and a polynomial. So this becomes y to the power 4 by 4 plus y square by 9 minus y y cube by 3. This is equal to y to the power 4 minus y cube by 3 plus y square by 9. Expand. Okay. Now we have finished problem number 2. Let's do the remaining part of problem number 1, which I missed. That is part 3. Which one I did? Okay. Part 3, problem 1 is 7a plus 9b multiplied by 7a plus 9b. So this is equal to 7a plus 9b whole square. Now we apply the formula of a plus b whole square. A square plus b square plus twice a multiplied by b. So this is equal to 7a square is 49 a square, 9b square is 81 b square, plus 2 into 7a into 9b, which is 14, that is 126 ab. And we have the 6. Problem 1, part 6. It is 5 by 6 a square plus 2 multiplied by 5 by 6 a square plus 2. This is equal to 5 by 6 a square plus 2 whole square. Now applying the formula of a plus b whole square, this is equal to a square plus b square plus 2 into a into b. So this is equal to 25 a to the power 4 by 36 plus 4 plus uh, 10 by 3 a square. So this is equal to 25 a to the power 4 by 36 plus 10 by 3 a square plus 4. Okay. Now let's continue with problem number 3, that is expand. The first part 1 is 8a plus 3b square. So we have to use the formula of a plus b whole square. This is equal to a square plus b square plus twice a into b. So this is equal to 8a square is 64 a square plus 9b square and plus 48 ab. Okay. Part 2 is 7x plus 2y whole square. This is equal to a square plus b square plus twice a into b. 7x square is 49x square, 2y square is 4y square plus 2 into 7x into 2y, which is 28xy. Okay, let's do part 3. Uh, 5x plus 11 square. So this is a plus b whole square. So a square plus b square plus 2 into a into b. This is equal to 5x whole square is 25x square plus 11 square is 121, and we have 2 into 5x into 11, that is how much? 110x. So this is equal to 25x square plus 110x plus 121. Okay. Part 4 is 3x by 4 plus 2y by 9 square. So this is a plus b whole square. So we have a square plus b square plus twice into a into b. This is equal to 9x square by 16 plus 4y square by 81 and plus 2 into 3x by 4 into 2y by 9 is 36, 6, 1 by 3, xy by 3. Okay. Part 6 is 9x minus 10 square. So this is a minus b whole square, which is a square plus b square minus twice of a multiplied by b. 9x square is 81 x square, 10 square is 100, and minus we have a 180x. So this is equal to 81x square minus 180x plus 100. Uh, 6. Okay. Part 7. Part 6, 7. Okay. Part 7 is x square y minus y z square square. So this is a minus b whole square, which is equal to a square plus b square plus twice a into b. So this is equal to x to the power 4 y square plus y square z to the power 4 and plus 2 x square y square and z square. Let's do part 8. X by y minus y by x square. Now you will notice that the two terms, it is a minus b whole square, where a and b are reciprocal of each other, because x by y is the reciprocal of y by x. So if you remember that a minus 1 by a whole square is equal to a square plus 1 by a square minus 2. If you remember this, then it is fine. Otherwise, you can directly apply the formula of a minus b whole square, which is a square plus b square minus 2 into a and b. So this is equal to x square by y square plus y square by x square minus, as x by y and y by x, they are reciprocal of each other. We know that a number and its reciprocal, product of a number and its reciprocal is always equal to 1. So this is equal to minus 2. Okay, let's do part 9. 3m minus 4 by 5 n square. So this is a minus b whole square, which is equal to a square plus b square minus twice of a multiplied by b. 3m square is 9m square plus 4 by 5 n square is 16 by 25 n square, and minus 2 into 3m into 4 by 5 n is equal to 624, 24 by 5 m into n. This is the final result. So that was we completed first three problems. Okay. Now problem number 4, find each of the following products. Okay. Problem number 4. Part 1 is x plus 3 multiplied by x minus 3. We see it is of the form a plus b into a minus b, which is equal to a square minus b square, a square minus b square, which is equal to x square minus 9, x square minus 9. Okay. Part 2, 2x plus 5 multiplied by 2x minus 5. So this is also of the form a plus b into a minus b. So the answer is a square minus b square, a square minus b square, which is equal to 4x square minus 25. Okay. Now I am not doing 3. It is very similar. So all the problems, subproblems of the problem 4, they are of the form a plus b into a minus b, a plus b into minus b. Let me do a few more. Let's say, let me do 5, which is 5x square plus 3 by 4 y square multiplied by 5x square minus 3 by 4 y square. So we can clearly see it is a square, a plus b into a minus b, where a is 5x square and b is 3 by 4 y square. So the result will be a square minus b square, a square minus b square. So 5x square, square of 5x square is 25 x to the power 4, and square of 3 by 4 y square is 9 by 16 y to the power 4. Okay. Let's do 7. It is x plus 1 by x multiplied by x minus 1 by x. So this is also of the form a plus b into a minus b, where a is x and b is 1 by x. So the formula is a square minus b square. Uh, 8, it is 1 by x plus 1 by y multiplied by 1 by x minus 1 by y. Now you can consider this as, even though you can directly apply the formula a plus b into a minus b, because it has the form a plus b into a minus b, where a is 1 by x and b is 1 by y. So the result will be a square minus b square. As we know, a plus b into a minus b is a square minus b square. So the result will be a square minus b square. This is equal to 1 by x square minus 1 by y square. If you simplify this, it will be y square minus x square divided by x square by y square. Okay. Let's do problem number 5. It says using the formula for squaring a binomial, evaluate the following. It has asked to find 54 square. We have to apply the formula of a plus b whole square or a minus b whole square. Now, 54, how can we split 54 in the form of a plus b or a minus b? Now, you must do this very carefully so that it is easy to find a square and b square, because a plus b whole square, it is equal to a square plus b square plus twice ab. So this can be written as 54 can be written as 50 plus 4, and we have square. So this becomes in the form of a plus b whole square. Now this is a square, that is a square plus b square plus twice a into b. Now 50 square is 2500, 4 square is 16, and we have 2 into 50 into 4, that is 400. So now this becomes 2916. Okay, let's do part 2, that is 82 square. Now 60 minus 6. Now 54 square you could have also written as 60 minus 6 square. This would also work because 60 minus 6 is also 54. Okay, so 82 square, 82 you have to write in the form of a plus b or a minus b, so that it is convenient to compute a square and b square. So I can write it as 80 plus 2 square. So it is of the form a plus b whole square, but a is 80 and b is 2. So this will be equal to a square plus b square plus twice a into b. 80 square is 6400, 2 square is 4, and we have 2 into 80 into 4, that is 2 into 80 into 2, that is 320. So this is equal to 6724. 6724. Okay. Let's see part number 3, which is 103 square of 103. Now clearly I will write 103 as 100 plus 3 square, a plus b. So it is now in the form a plus b whole square. The idea is to split the given number as a plus b or a minus b, such that either a or b has ending 0, and one of the a and b is a single digit number. So now we have 100 plus 3 whole square, which is of the form a plus b whole square, and it will be a square plus b square plus 2 into a into b. 100 square is 1 and 4 zeros, plus 3 square is 9, and we have 2 into 100 into 6, 2 into 100 into 3, that is 600. This is equal to 100600 9. Uh, 704, square of 704. 704. So I will write 704 as 700 plus 4 square. So I have the form a plus b whole square, where a is 700 and b is 4. So this is equal to a square plus b square plus 2 into a into b. Now 700 square is 49 and 4 zeros. 4 square is 16, and we have 2 into 700 into 4, that is 700 into 8, which is 5600. So this is equal to 495616. Okay. Question number 6. So this was all this for problem number 5. All the numbers we expressed as sum of two numbers. So we use the formula a plus b whole square. Now problem number 6. For problem number 6, all the numbers it will be convenient to express in the form a minus b. So problem number 6, part 1, the number is 69 square. 69 square. Now definitely we will not write it as, even though it is correct, you can write it as 60 plus 9 whole square. This is fine. But the more appropriate or easy way of writing 69 is 70 minus 1. This will be more easy in calculation. So 69 square is 70 minus 1 whole square. We have the now formula of a minus b whole square, which is a square plus b square minus 2 into ab. 70 square is 4900. 1 square is 1, and we have minus 140. So this is equal to 4900 minus 139, because minus 140 plus 1 is minus 139. So this is equal to 4761. 4761. Okay. Part 2 is 78 square. So definitely I would like to write it as 80 minus 2 whole square instead of 70 plus 8 whole square. Okay, so this is equal to 80 square plus 2 square minus 2 into AB, that is 2 into 80 into 2. 80 square is 6400 plus 2 square is 4 minus 320. This is equal to 6400, and plus 4 minus 320 is minus 316. So this is equal to now 4806. So 6084. 6084. Now let me quickly check if I am doing it correctly or not. So 78, I am using a calculator to check whether the answers are correct or not. 78 square is 6084, that is correct, and 69 multiplied by 69 is 4761, that is also correct, and 704 multiplied by 704 is equal to 495616. Okay, correct. Okay, let's do part 3. It is 197 square. Now definitely I would like to write it as 197 as 200 minus 3 square. So this is equal to a square that is 200 square plus b square, that is 3 square. Now minus twice a and b, minus twice ab. 200 square is 4 and 4 zeros, plus 3 square is 9, and we have 2 into 200 into 3 is 1200. Okay, now we have to do this simplification. This is 4, this is 40,000, and minus you can, now the simplification you can do it in any way you like, whichever is convenient to you. So you can write it as 40,000 40,009 minus 1200, which is equal to 90883 38809. Let me check if this is correct or not. 197 multiplied by 197 is 38809. Okay. Okay, so we have another part 4, which is 999 square of 999, 999. This is equal to 999 is equal to 1000 minus 1. So we have 1000 minus 1 square. So this is equal to a square plus b square minus 2 into a into b. So this is equal to 1000 square is equal to 1 and 6 zeros. We have plus 1 and we have minus 2000. So this is equal to 1,000,001 minus 2000. So you have to do it very carefully, the subtraction and addition. 2,000 1,00899. So it is 998,001. I'm not sure if this is correct or not, but let me check it. 999 multiplied by 999 is equal to 998,001. Okay, it is fine. Okay, problem number 7. Problem number 7. Find the value of, okay, first one is 82 square minus 18 square. So we can see it is of the form a square minus b square. So the answer is a square minus b square is a minus b multiplied by a plus b. So this is equal to 82 minus 18 is 64 multiplied by 82 plus 18 is 100. So this is equal to 6,400. Part 2 is 128 square minus 72 square. So this is also a square minus b square. So the answer is a minus b multiplied by a plus b. So a minus b is 128 minus 72, that will be 6 and 56, and 128 plus 72 is 200. So this is equal to 11200. Okay. Uh, part 3 part 3 is 197 multiplied by 203. Now it is product of two numbers. Now definitely you have to somehow uh, express the product of two numbers as a square minus b square, just like we know that a square minus b square is expressed as product of two numbers, that is a minus b multiplied by a plus b. So in the problem you are given a minus b and a plus b, that is a minus b is since 203 is greater than 197, definitely a plus b is given as 203 and a minus b is given as 197. So you can then, from the fact that a plus b must be equal to, probably a plus b is equal to 203 and a minus b is equal to a plus b is equal to 203 and a minus b is equal to 197. You can now find the value of a plus b. Now you can clearly see that 197 is 200 minus 3 and 203 is 200 plus 3. So clearly you see it is of the form a minus b into a plus b, which is equal to a square minus b square. So this will be equal to a square minus b square, which is equal to 200 square is 40000 and minus 9. So this is equal to 1 and 9 9 39 3999 3999 Okay. 7 part 4 is 198 multiplied by 198 minus 102 multiplied by 102 divided by 96. Now you can see this is equal to 198 square minus 102 square by 96. Now the numerator is of the form a square minus b square, where a is 198 and b is 102. So it will be a plus b multiplied by a minus b, and we have divided by 96. Now 198 plus 102 is 300 multiplied by 198 minus 102 is 96, and we have divided by 96. So the answer is 30. Okay, let's do part 5. It is 14.7 multiplied by 15.3. Okay, now 14.7 is 15 minus 0.3 and 15.3 is 15 plus 0.3. So you can see it is of the form a plus b into a minus b, where a is 15 and b is 0.3. So this is equal to a square minus b square. So this is equal to 15 square is 225 and 0.3 square is 9 by 100. 9 by 100, because 0.3 is 3 by 10 and 3 by 10 square is 3 square by 10 square. Okay. Now I will not simplify this. I will leave it to you. So 225, 225 minus 9 by 10 is the result. Okay. So part 6 is 8.6 8.63 square minus 1.37 square. So this is also of the form a square minus b square. So this will be equal to a plus b multiplied by a minus b. Now a plus b is equal to 10. A plus b is equal to 10 and a minus b is equal to uh, 6, 13, 42.7. So this is equal to 72.6. Okay. Let's do problem number 8. Find the value of the expression 9x square plus 24x plus 16 when x equals to 12. So the given expression is 9x square plus 24x plus 16. We have to find the value of this expression when x equals to 12. Now if you try to directly put the value of x as 12 in this expression, it will be a lengthy calculation. You must realize what you have to simplify this given expression in the form of using some algebraic identity, like 9x square is 3x whole square, 16 is 4 square, and you can see 24 is 2 into 3x into 4. So clearly we can see this is of the form, this is a square plus b square plus 2 into ab, which will be equal to a plus b whole square, a plus b whole square. Now you can put the value of x, that is 3 multiplied by 12, because the value of x is 12, plus 4 square. This is equal to 36 plus 4 square. This is equal to 40 square. So this is equal to 1600. 1600. Okay. Question number 9. Find the value of the expression when x equals to 11 and y equals to 4 by 3. So the given expression is 64 x square plus 81 y square plus 144 xy. Now we have to somehow, so 64 x square is 8x square, 81 y square is 9y whole square, and you can see that 144 xy is equal to 2 into 8x multiplied by 9y. So we have a square plus b square plus twice ab. So this will be equal to 8x plus 9y whole square. Now you can put the value of given values of x and y. So x is given as 11 and y is given as 4 by 3. So this becomes 88 plus 12 square. So this is equal to 100 square. So this is equal to 10,000. Okay. Let's do. I will not do the problem number 10, which is very similar to 8 and 9. So Let's do problem number 11. We have two parts. So it is given that x plus 1 by x is equal to 4. We have to find the value of x square plus 1 by x square. Now, in the you must so you can do it in a different way. A square plus b square. A square plus b square is equal to, you must know that a plus b whole square minus twice ab. Uh, a square plus b square is equal to a plus b whole square minus twice ab. So we can say that x square plus 1 by x square is equal to x plus 1 by x whole square minus 2 into x into 1 by x. So x plus 1 by x is given as 4. So this becomes 4 square, and minus 2x into 1 by x is 2. So this is equal to 16 minus 2 equals to 14. Equals to 14. Now, if you do not remember the formula a square plus b square is equal to a plus b whole square minus twice ab, then you can directly also use the formula a plus b whole square. Because you know that in this problem, a and b are reciprocal to each other, as x is reciprocal to 1 by x. X and 1 by x are reciprocal to each other, so their product will be equal to 1. So that is a that will help in solving the problem. Okay, so that was part 1, and part 2 is to find the value of x to the power 4 plus 1 by x to the power 4. Now, we have to find x to the power 4, x to the power 4 plus 1 by x to the power 4. Now, if you remember this formula, that a square plus b square is equal to a plus b whole square minus twice ab, then it will be easy. So this you can say as x to the power 4 plus 1 by x to the power 4 is nothing but x square plus 1 by x square square. So this is equal to, on the right hand side we have the form a square plus b square, which will be equal to a plus b, that is x square plus 1 by x square, a plus b whole square, and then minus twice a into b. Now we have already found the value of x square plus 1 by x square from part 1. We will use that fact. So x square plus 1 by x square was 14. So 14 square minus 2, which is equal to 14 square is 196. 196 minus 2 is equal to 194. 194. Okay. Now, okay. So problem number 12 is similar to problem number 11, but in this case, we have given x minus 1 by x as equal to 5, and we have to find in part 1 the value of x square plus 1 by x square. Now, another formula of a square plus b square is equal to a minus b whole square plus twice ab. So a square plus b square is, you can express it as a plus b whole square minus twice ab, or a minus b whole square plus twice ab. So this will be x square plus 1 by x square. We can write it as a plus b whole square, sorry, a minus b whole square, a minus b whole square plus twice ab. Now x minus 1 by x is given to be 5, so 5 square, and plus 2 into x into 1 by x is 2. So this is equal to 27. 25 plus 2 is 27. And also we have to find the value of part 2. We have to find the value of x to the power 4 plus 1 by x to the power 4, which is equal to x square of x square plus square of 1 by x square. So again we are having the form of a square plus b square, where a square is x square and b, where a is x square and b is 1 by x square. Okay. Now we will have to use the fact from the previous part, that is, we know the value of x square plus 1 by x square is 27. We will use that fact. So so this is equal to, we will use the fact that a square plus b square is equal to a plus b whole square minus twice ab. So this becomes x square plus 1 by x square, this whole square, minus 2a into b. So x square plus 1 by x square, we already know from part 1 is 27. So this is 27 square minus 2, which is equal to how much is 27 square? 49, 18, 729. So 729 minus 2 is equal to 727. 727. Okay. Find the continued product. Problem 13. Problem 13, part 1 is x plus y, x plus 1 multiplied by x minus 1 multiplied by x square plus 1. Now if you consider the first two product, that is x plus 1 into x minus 1, we can apply the formula of a plus b into a minus b is equal to a square minus b square. So we will have, if you consider the product of the first two, product of x plus 1 and x minus 1, it becomes x square minus 1, using the formula that a plus b into a minus b is equal to a square minus b square. So we have x square minus 1 multiplied by x square plus 1. Again we have the form a plus b into a minus b, where a is x square and b is 1. So this becomes a square minus b square, that is a square minus b square, which is equal to x to the power 4 minus 1. Part 2, x minus 3 multiplied by x plus 3 multiplied by x square plus 9. If you consider the product of the first two, product of x plus 3 and x minus 3, it becomes, using the formula a plus b into a minus b is equal to a square minus b square, it becomes x square minus 3 square, and then we have x square plus 9. This is equal to x square minus 9 multiplied by x square plus 9. So again we have the form a plus b into a minus b, which is equal to a square minus b square. So we have a square minus b square, which is equal to x to the power 4 minus 81. Now the part 3 and 4 are very similar to part 1 and 2. So I'm not doing part 3 and 4. It is exactly the same way you have to do as I did part 1 and 2. Okay, let's do problem number 14. It is given that x plus y is equal to 12 and it is given xy is equal to 14. We have to find the value of x square plus y square. Okay, so it is good if you remember the formula that x square plus y square is equal to x plus y whole square minus 2xy, or it is also, since we are given the value of x plus y, we will express you will use the formula x square plus y square is equal to x plus y whole square minus 2xy. If we were given the value of x minus y, we would have used the formula that x square plus y square is equal to x minus y whole square plus twice ab plus twice xy. So this is equal to, we know x plus y is 12 square minus 2 xy is given to be 14. So this is equal to 144 minus 28, which is equal to 1 6. 116 is the answer. Okay. Problem number 15 it is given that x minus y is equal to 7 and xy is equal to 9. We have to find the value of x square plus y square. So x square plus y square, we know using x minus y is x minus y whole square plus twice xy. So x minus y is 7 square plus 2 into 9. So this is equal to 49 plus 18. This is equal to 67. So this brings to an end in solving the problems of exercise 6D. I hope in solving these problems you will get an idea how we are applying the algebraic identities to solve this kind of problems. So if this video was beneficial to you, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So in the next video, I will solve the exercise 6E, which is objective questions based on the chapter of operations on algebraic expressions. So stay tuned for the next video. After that video, I will solve, no, there is no test paper. So after that, I will solve two sample test paper 1 and 2, which will be relatively harder problems. So please stay tuned for the upcoming videos. Thanks for watching, and until the next video, take care and bye.